everyone. I am Aditi Arora from ABES Engineering College, Ghaziabad. In today's video lecture, we will be covering the problem that is producer-consumer problem. We already have discussed about this problem earlier in our video lectures. In today's video lecture, we will again provide a quick summary of producer-consumer problem, and mainly we will focus on the solution of producer-consumer problem using semaphores. We have already have a detailed discussion on semaphores. What are semaphores? They are basically the software-based solution to provide a solution for critical section problem. So once again, we will be using the concept of semaphores in order to understand that how we can provide synchronization among the two processes, that is producer and consumer. So here, we already have studied that producer-consumer problem is also called as bounded buffer problem, which is a classical problem of synchronization. There is a buffer which is of size n, and it is shared between two processes, that is producer and consumer. Producer is producing the data items and putting it in each slot of the buffer one at a time, and consumer is consuming one item from each slot. Now, the producer tries to insert the data when there is an empty slot in the buffer, and the consumer tries to consume or remove the data from a filled slot in the buffer. Here we can see that we have used two variables, that is in and out. In means this denotes the current slot where the producer will produce the item and place it in the slot, and out points to that index of the slot from where the consumer will consume the data item. Okay, now this slide is important. The problem here is that we need to ensure that this problem should not occur, is that the producer should not insert the data item when the buffer is already full, and the consumer should not remove any data item from the buffer when the buffer is itself empty, right? So we need to ensure that the producer and consumer should not insert or remove the data simultaneously. So here we provide, first of all, the consumer and the producer code, that how consumer and producer will work. So here you can see that initially the buffer size is n, means maximum n items can be produced or consumed from the buffer. And there is a variable called as counter, which is shared by both producer and consumer, and whose initial value is 0. Now, the producer is using this counter value to increment it by 1 whenever the producer produces an item, right? So, producer will increment the counter value by 1 whenever it produces one item in the buffer, whereas the consumer will decrement the value of counter by 1 whenever the consumer consumes one item from the buffer. So here you can see we have the code for producer. Now producer will check the while condition. So counter value initially is 0 and the buffer size is n. So obviously this while condition will be false. So when this while condition will be false, producer will execute the next instruction, and it will produce an item and place it in the IN index of the buffer. So this is our buffer of n slots, and this is the IN and this is out. Both the IN and out are pointing to the same slot initially. So say for example, this index is 0, right? So producer will produce an item and place it in the 0th index of the buffer, and it will increment the in value in plus 1 percentile buffer size. So this is your in is 0, 0 plus 1, that is 1 mod buffer size, which is n. So the answer will be 1. Now the next item that will be produced will be placed here. So in will be move one step forward, right? So, and then the producer will update the value of counter by 1. So now the counter value is 1. So in this way, the producer code can run n times and it can produce n maximum items. This is the first case when producer keep on producing the items and it can fill all the n slots, right? The other way around is that when producer have not produced any item, so consumer comes and it tries to consume the item. So we need to ensure that consumer should not consume from already empty buffer. So here the consumer will check counter value initially is 0, 0 equal to 0, the condition will be true, and when the condition will be true, consumer will keep on looping in this while condition, and it will do nothing. But when the counter value is 1, means there is one item in the first slot, so the consumer can consume the item from the out index, and out index initially is pointing to the 0th index, that is first slot. So the consumer can consume its item from this slot, right? And again, the out value will also be updated. Out plus 1. Out was initially 0. 0 plus 1 mod buffer size. It will be 1. So it means that the next item will be consumed from the updated value of out variable. Then the consumer will decrement the counter value by 1. The counter value was 1. 1 indicate means one item was produced. Now from 1 it will be again become 0. 0 indicate that now the item have been consumed by the consumer. So this is how producer and consumer code will run. Now, as you can see that both the producer and consumer are using this counter variable. This is a shared variable. So where the problem will occur when both producer and consumer try to use this counter variable at the same time, means producer is trying to increment the value by 1 and the consumer is trying to decrement the value of counter by 1 at the same time, then the problem arises, right? So say for example, we have item here, we have item here, and we have item here, right? We have the counter value as 4. Now, if producer and consumer once again try to execute these instructions at the same time. So consumer producing the item and it will try to increment the value by 1. So it will try to make it 5. But at the same time, counter variable is getting decremented by the consumer and consumer will make this value as 3. So what will be the final value? 5, 3 or 4? So final value ideally should be 4, but it is coming either 4, 5 or 3, which is wrong. So here we need to ensure that the counter variable should be used in a mutually exclusive manner. When producer is updating the counter value, consumer should not use it. And when the consumer is updating the counter value, producer should not access the counter variable. And this synchronization we will achieve using semaphores. Now to solve the producer consumer problem using semaphores, we are taking here 3 semaphores, whereas 2 are counting semaphores and 1 is the binary semaphore. We already have a discussion on the types of semaphores. Binary semaphore means it can take only the value of 0 and 1, whereas counting semaphore can take any value, and semaphore is basically a integer variable which can be used with 2 operations, that is wait and signal operation. So wait operation basically decrement the value of semaphore by 1 and signal operation basically increment the value of semaphore by 1, right? So here we have one semaphore called as empty whose initial value is n, means initially the buffer is empty. N slots in the buffer are empty. Another counting semaphore is full, whose initial value is 0. That indicates that there is no item in the buffer yet. Full is 0. So the next is mutex, which is a lock also, and whose value is 1. And it is a binary semaphore, which is basically used to acquire and release the lock. So whenever a producer or consumer will try to access the counter variable, first they need to access the mutex. Only then they can acquire or they can access the counter variable. They can update the counter variable. Now, this is an important slide to understand. We have the producer code and consumer code, and both the processes are using the same semaphores, empty and full, which are counting semaphore, and mutex is a binary semaphore. So let us say first the producer process executes. So it will apply wait operation on the empty semaphore. Empty semaphore has the initial value n, and when we will apply the wait operation, that means n will be changed to n minus 1. Means now the producer is trying to produce one item, and we also apply wait operation on mutex. Mutex value initially is 1, and when wait operation is applied on mutex, it gets changed to 0. It gets decremented by 1. So it means that now producer have acquired the lock to produce one item and place it in the first slot of the buffer. So producer produces the item and place it in the index of the buffer. So here one item is produced, right? Now the producer applies signal operation on mutex, which is 0, and now it will become 1. Means the producer have produced one item. Now the consumer can consume that item, and it will apply the signal operation on full semaphore. So what is the value of full? Full semaphore is initially 0, and it will turn to 1 because signal operation always increment the value by 1. So that means that now one item have been produced and it is placed in the first slot of the buffer. Now the consumer can come. Consumer will apply wait operation on the full. So what is the value of full? That is 1. Now the consumer can apply wait operation and it can turn it into the value 0. And again, in order to consume the value, in order to consume the data from the buffer, consumer require the lock. So it will be requiring mutex lock by applying wait operation. So what is the value of mutex here? It is 1, and then consumer will change it to 0. And now it will decrement the counter value by 1. Means it is consuming the item produced by the producer. And once it consumes the item, again it will release the lock. Again the value will be 1, and it will also apply signal operation on the empty semaphore. What is the value of empty semaphore? That is n minus 1. So now it will again be changed to n. Means now this item have been consumed, and again n slots are empty. So one item have been produced by the producer and that item have been consumed by the consumer, right? This is one case when producer and consumer are alternatively using the mutex lock and producing and consuming the item in alternatively, right? So the second case is that when the producer keep on producing the item. So how many times producer can run? Producer can run n times and produce n items. Okay, this is the maximum size of the buffer. And when the buffer size is full, now the producer code will not run. Okay, n iterations के बाद producer code नहीं चलेगा. Then only consumer code can run and the consumer can fetch the items from the buffer. So this is how we have provided synchronization between producer and consumer, because here whenever the producer will try to increment the value of counter, then it has to do it by acquiring the lock first and then releasing the lock. And whenever the consumer is consuming the item and decrementing the value of counter variable by 1, first it has to acquire the lock, and once consume the item, it has to release the lock and update the full and empty semaphores. So this is how we can provide the solution to producer-consumer problem using semaphores. These are the references that we have used to prepare the content. Thank you.